So we have set up a pseudo line boring setup so that we can show things, even though we don't really need to be doing line boring stuff right now. A gap there, and a gap on that side. That means that either that's uneven or the square's not square. Don't really matter which. It's somewhere close in there. We need a welder. That was one years ago, a friend of mine, he was telling his dad, we gotta have a welder to do this job. And his dad pointed at me and said, John can weld. And he's like, Dad, I can weld too. We need a welder, the machine. Oh. But he really felt like his dad was putting him down when his dad pointed to me, you know. The kid could weld. He hadn't welded quite as many years as me, but he could weld. It was what they needed was the machine, the welder. But we need the welder, a welder, yes. The table is our make-believe bucket right now. We're going to start welding supports on here, and we will start out with this one here. I'll weld on an angle, and I'm going to weld to the table first, since that's the part that I grounded. Gotta turn the machine on. Now you'll notice that pulled away, and you always want to think about your amount that it's going to pull as you're doing this kind of stuff. So if I were to just force it over, of course, to this, we'd be missing what we want to have for alignment. I'll use my vice grip hammer there. Now, we can move these again afterwards, but you do want to get your alignment relatively close, and you don't want to be pulling things when you're welding. Also, it's nice to be able to put your welds in places where they can come back out easily if you want to. I don't think my hood is working correctly. It's on high sensitivity for some reason. Maybe I got confused last time I played with it. So I do remember changing the sensitivity because it was fussing with me then too. Or maybe it's gotten old and not working as well. Now, why did I weld them both back here? I welded them both back here, so when we go to take this apart, after we pull the bar out, we can just bend that bearing and it will come away from those two welds. Now, lots of different ways to do this. You always want to think about structure. And what we're going to do here is we're going to brace that other angle that we put on there. And you can get off a whole bunch and still be okay. You don't want to have big gaps to fill where it's going to pull stuff, but you can be pretty creative and just kind of go free form. Now, why, which I'm still going to weld that a little bit more, why did I go and make this brace angle here instead of just going to this strong piece with a couple little stubs of angle? And the main reason was because I wanted to show another way to do it in case you had something you couldn't weld to there. But for this exact thing, yeah, just some pieces of angle sticking out welded to each of these, or even just bar would work plenty fine. And we'll do that on the other side. We'll cut a couple little pieces angle. We'll do it different. I spent about 5 years doing line boring all the time, but now I do line boring once every maybe 3 years. So if I'm a little rusty, that's good. As I'm remembering things, maybe it'll help me mention them more. So we need a couple pieces of angle iron, and I'm not going to use the portaband because we got other things here, but I tossed it out because that's really handy when you're doing this in the field and you don't have a bandsaw nearby. You portaband. You cut stuff off as you go. When you want to take it back apart, you can portaband through and then knock your welds of your pieces in multiple directions. It just works easy. Want somewhere around a 3 to 4 inch piece of something. And a lot of times, even if you have something, you don't even have to, like I was just talking about using angle iron. Well, here's a perfect angle iron replacer. And it's, oh yeah, look at that. It was meant to be. That's exactly the right size I wanted since I found it. Now this is with our first stuff we're doing here. This is just going to be with a drill motor powering it. And if that one won't do it, then we'll use the regular Milwaukee one I've used before. Now you can see over here, if we look at this piece I welded on, see how there's a little bit that's touching and a whole bunch of gap. You don't want to pull in here and just weld in that gap because it's going to want to pull a whole bunch. What you want to do is you want to weld some beads onto this, bring it up and get it to where it touches this. You want to just build them up across first instead of trying to fill in the gap and have it shrinking. So you see, I filled that all up above the weld. I didn't actually make any weld to this piece yet, because that's all metal that if you filled it right in between the two would shrink up and you'd pull the piece in a long ways. Now I can make another weld, again, have that come out a little bit further. You might not see it as well, but I won't be welding to this. I'll be just building the height of that weld. Actually letting the slag fall over on top of this piece, which if I was trying to join the two would be a bad weld. It would be leaving an inclusion there. But you can see now where the metal's over the top of this one a little bit, and now we can weld them together and it won't pull. That is, relatively. There'll be some pulling, not nearly as much. Now, instead of doing the same thing down here, because that's a pain, and because part of this is trying to explain different little ways to do things, we're going to do something different for that situation. And we're going to use one of the, oh, nope, I got one right here. I was going to use something that you do a lot of times on this, is you will use a nut, an old nut, a bolt, anything you got for a filler. It don't matter. And you can see I'm using my absolutely perfect clamp. It's a hand clamp. You know, some of them are operated by screws, some by hydraulics. This one operates strictly by hand. Probably should have just gone with 1/8 inch rod. 1/8 inch rod is a little bit, it was a light angle is what I thought about grabbing the 332, and that's what we're using, so I'll keep on. 1/8 inch is pretty good for tacking this stuff up. You can use whatever you want to. A lot of people use wire feed. I just find the wire feed, for me, is a little bit harder to know where the wire's hitting at first as you're looking through the nozzle. Okay, now we got our, when you're doing this, now I've got this temporarily somewhere near center. You can see I've got some little bolts and nuts in here holding it. A lot of different things you could do. Like I say, one of the things that people use is cones, which this is not even round at all. You got to watch a little bit. I should have sprayed my bar down a little bit more. I had sprayed it before, but you don't, because you can get spatter and stuff on your bar is a problem. You want to leave some room. Your bit's got to be able to come through. You got to be able to make an adjustment on your bit. You want it close for strength, but at the same time that you want it close, if you're too close, it's really hard to work the tool bit. So you got to compromise. I'm going to probably leave this a little further than I normally would. We'll be able to see better, and it should still work. Yeah, look at that. Exactly the length we wanted.
Long enough?
Long enough. If they're too long and they get in our way, then we'll cut them off after the fact. If it looks like I'm doing this kind of crude, that's part of the point, is that this does not have to be art. This does not have to be pretty. I'm not wearing welding gloves today because I wanted the dexterity more for being able to move things around than the protection from the welding. These particular bearing setup here we used before for doing a loader bucket. When we did the loader bucket, we did this off of the boring mill. It's what we use for power. Set a little hot. I like and hate these type clamps both. They grab tighter when they grab, but they do tend to get burnt out just a little bit when you're as far as what fits good for small rod. Now, we're going to add, I don't want it up in my way, I'm going to add a diagonal brace across there. It's actually kind of amazing how much you really don't need for welding stuff on these. It's more a matter of structure and points, more so than a huge piece to weld the two together. Yeah, not that one. That's going to poke me. Then I'd have to cut it off. Well, let's just do this different, just for variety. And come up off the table. That'll brace it too. Yeah. Now, little question here. Do we want to just leave them out there? Or do we want to put a third bearing out here? Oh, that's right, I forgot. I had bolts in there yet. It's amazing. It stayed here, just braced up like that. I was told to mention that. Because I was not amazed. Myself, I figured there would be no question, but I guess that there was things happened here and came close to hitting it. So that was a possibility. Anyway. And yeah, I had no doubt that everything would be just like I left it here. Of course, you on the video don't know yet that I was gone. I was gone for a couple weeks. And at the end of my trip, went and saw my sister. And I came back, saw her for Thanksgiving. So, see, it's harder to get in here once those bearings are in the way. Okay, that's out, that's out. Oh, got another one. Ooh, tumbled. Okay, now it turns better. Okay. And I'm going to go ahead. And we have this here yet. And here's one of the things. Your bar, yep, okay. You need your bar to slide. If your bar doesn't slide, I grab a rag too. I'll make a very serious couple of points with that. Okay. There is clearance between your bars and your shaft. And I will just keep it simple. I was going to put a third bearing. Well, we might put another bearing out there too. Since the whole idea is to instruct and show things, it's not really a matter of getting anything done. Yeah, we probably put a third bearing out there, but there's a little bit of clearance. Your shafting, generally, you're using shafting that's like your 4140 shafting. Normal size on it will be 1 all the way up to 3/1000ths of an inch under the standard size. Your bearing will generally be the size that the spec is for it, up to 1/1000ths over. And yeah, some of that's a little warm, but the bearings aren't really yet. So here is what happens. Let's see. Let's pull this back, and I want to actually cock that bearing. Not out yet. Okay. So now I've cocked that bearing, and help me get it just barely to where it'll go in there, Bert. Which way have I got to go? I got to move the bar that way?
The end of it.
Okay, okay, just, yeah, okay, either way. Just barely where it goes in. I don't want to have it go in easy.
Try it. There you go. You're in.
Okay, okay. Okay, now, it slides right now, but not easy. okay? And that was because this bearing here is slightly cocked. And what I did was I had on purpose put it to one side and then moved it just enough to get into the other hole. And it does move, but it doesn't move easily. This one down here is probably still pretty well in line. Not quite, okay? Because so what you do on this situation, there's a multitude of things you can do, but a really, really simple one is take a hammer and you just hammer around the collar. And what that does, it will move it to one side to where the bar is against that clearance that's in there, but it won't move it past so that it takes a new set in a different place. And then it moves way easier. You want it to move easy. Now, when it's really right, you should be able to come in here and hold the bearing and turn the bar. Now, there's a little dirt on this one, so it's a little harder to hold than what I'd really like. But yeah, this one here is really easy. You just hold it and spin it. We couldn't have done that before. Now, I cannot easily get it back to that bound position now that I've got it straight and in there. But you can see how easy it is to get it into the straight position. That's the easiest trick. Now, another way to do it, if you're not doing that, is we'll pull this back out. I got some cruds on here I don't want. And we'll grab a stone. Anytime you have to force your bar, it's not right. It's just not right. Always look at your areas next to your holes, of course, because you're likely to pick up burrs, chips, whatever. The lines that you see in the bar from where it's scratched along, like where we were fighting through things. Wipe it down. Little extra lubricant of some sort don't hurt. I don't know what that noise was. But okay, now the other way you can do that is you can see out there there's a lot of clearance, a lot of movement. So if we had it too far one way like it is there, now we could take it in the end and we could move it so it's back and forth as we go into the bearing. And you can feel your spot for it. See, I did that without Bert even looking for me. But it's hard. You got to get it in with it all pushed to one side and making it bound up. Now, so if it's so hard to get it bound up, why am I concerned? Shouldn't it just naturally come out? And it doesn't. The reason it doesn't is because you want to move your center a little bit. You loosened a bolt on a bearing. You moved a bearing down. Now it was trying to pull to one side as it was moving in line with, per se, 3 bearings. The 2 of them, if I move it down and tighten it, it may very well come in there. It gets harder with 3 bearings than it is with 2. And like we were saying, since we're doing this for explanation, we might just as well throw on a 3rd bearing. And this one's been used before. Oh. That was the one I had the inside all scored up on because I found out the hole is too small. It hasn't been used. It's just got some, maybe we tried it? I don't know. But yeah, that one there, it actually needs to be honed a little bit. It was a new bearing, but it does not fit. And if you run into that, you know, you gotta, don't just hammer it on. This has got to work out. If it don't work out, they're not good. And they got to be straight where they won't slide. But once they're straight, they'll slide. Okay, so I don't want to blow up the can, start fires, hurt my straps, any of the other fun. Let's just put it out somewhere. Yeah, let's put it out here. Okay, so we will Again, welded on. And since our ground is on our table, being aware of what's going on, we definitely want to make the first weld to the table. Okay, I'll call it enough anyway. But since we're doing welding, before we go to our next stage, this bar originally, we'll have to line that up a little better, but for starters, right there, and I have used, this one was on a boring mill. A lot of times when I'm doing a drill drive like this, what I will do is just run the boring bar. I like U-joints, but I'll run you can run them in line if you're really careful, but the magnet will base will try and come off. A lot of any little movement comes back to you, moves the drill a lot. What I like to do, let's see, we're going to be I'll use, what I was trying to say, I will use a, that's an interesting thing we hadn't thought about, our clearance to our base there for our U-joint. What we usually use is a little itty bitty drive line from a socket set. And we may have to make a different driver for this, because these big old U-joints that we were already set up for, well, I've changed the end so that it will work with this. Doesn't really look like the U-joint wants to work with it, although it might if we get in just the right place here. Gonna be a little problematical. That can come up a little more. We really can't make much of a cut. Huh. Well, no, because that's just going to come down to the base, and even at an angle, just ain't going to let us have much movement. I want to do it with the cheapest drill we got here, which this is definitely our cheapest drill we got here. Darn it. Well, it's just what it is. So, really hadn't looked at the amount of travel we got on this either. I didn't put my tape measure in today. And I probably, well, at least 5. Yeah, we've got plenty to do that if we have our smaller bar. That's as far as down as it goes. Okay, so it's got quite a bit of travel. Yeah, that'll definitely do our bore that we're playing with here. But that bar, drive bar, is not going to work. So, yeah, we got to get something dealt with else. Okay. First off here, before we go putting our wonderful drill on it, actually I want two stands. Yeah, I'm going to want a second indicator stand. But we could start with one anyway. Turn that over. And you see it moving some. That could be just the run out in the bearing. This one here is slightly snug. So doing that again to, oh, it's actually binding there. So, that was part of the idea. I figured we would move this one to get it centered. Look at that, oh, it moved a little. Okay, but I want to know that that is actually loose. And it's good to check a little bit, see about how much your shaft flexes, because your shaft will flex. And even if this, even if the shaft is straight, you'll notice there's some flex. That's part of why you can get by with this. You can see how, so that's floating, how that can turn now again. Where a second ago I couldn't hold that and turn it. But that's part of why you get by with your bar not being aligned perfectly, is because the bar bends a whole lot more than you think. You'll see that even with the crankshafts and other industrial stuff. I want to get a second indicator here because I want one for the side and one for either the up and down or the bottom. It would be easier as far as for doing various displays and discussions and stuff if we didn't have work going on in the shop too. It can really be a distraction. The noises, the bother, the smoke. But we still have to make money here so that we can afford to do other things. So, one of the things here is, as we're turning this, and that's not running out very much there, but is to kind of get an idea of lifting up and down. And you're just sort of guessing sometimes, because if it lifts a certain amount down, certain amount up, you kind of got a little bit of a guess. And I try to get it so that where I think the center of the pressure, because you've got weight. The bar itself weighs something already. I should be able to pick it up a little bit and get a little more clearance than I am by pushing down. So try to find an even. And on this one here, we got some natural run out, which is a little bit more natural to see than the fact of the weight. So I got one up, 1.5 down, about even in between. So once we get those set, then as we start snugging our bearing, we can shoot for 0 on our 2 indicators. Now the easiest one to move is always your middle one. It would be harder to get a good movement on that one out there, because these two close bearings, even if they were evenly spaced, you've got more hangout here. Your movement is going to be more. So there's a little more guessing. When you don't have as much movement, there's not as much guessing about where it belongs. And when we're all done, even though it's snug down, it's going to run out a little bit regardless, because there's clearance between the bearing and the shaft. There's a little bit of clearance in them. A little rough spot in there, but anyway. Oh, I did not end up where I wanted to be on that one, did I? Did that move that much because of the bearing bore alignment? I don't think I moved the indicator. I might have. Yeah, let me just start over. Let me just start over. I don't know. It just seemed like a whole bunch more, but it may have moved right at the end. He'll do that sometimes. Right at the end of tweaking them, you get a little movement as you snug the bolt that last little bit. I wasn't paying enough attention to be absolutely sure. This is really not too bad. I mean, this, I could pretty much pick it to the top of this, tighten it up, and call it good in reality. The thing with the indicator is more of a difference when you've got 10 or 15 thousandths run out. You know, 1 or 2 is not that much. But when I was finally tightening it down and saw myself 3 thousandths off from where I thought I was going to be, that didn't really like that. I don't know if I bumped the indicator or if I actually had pulled it that much. That looks better to me, and it spins better too, which is one of my, like I say, one of my checks. When things are right, you can take and spin the bar inside of the bushings. A little bit of crud on it. Why are we advertising PB Blaster today? Because it's handy. It's what we happen to have in our can. It would have been some other thin, oily type stuff otherwise. Something's catching there. I think that bearing, I think it's got a burr on it. Not going to be a big problem right now. Just stay in between the bird's points, moves easy. Okay, so let's get set up to actually make a cut. So, our bit is going to be out here. Our drive bar is going to be this one. And we're gonna need someone to hold this and the plate and do stuff, and someone to tack welding. You shocked me pretty good last time.
Sorry about that. Can you let go? Whoa, okay, what do you want?
Okay, somebody want to hold this up? Line the shaft up as straight as you can. All the way down. Everything about lining it up. You have to hold still when it hurts. Part of that was the insulation from the paint. Apparently it shocked you too. Even though I thought I was doing a little different than Austin did, but probably not in reality. That paint on that thing is making it insulated. I'm gonna go ahead and grab some 1/8" rod, I think.
Okay.
It'll be better with a little more rod.